Alright, let's get our hands dirty and talk about something fascinating in the world of metal casting. Furnace slag build-up. Imagine you're making a giant, super hot soup of molten cast iron. Just like when you cook, you sometimes get a layer of scum or foam on top. In a furnace, we call this gunky stuff slag. It's a mix of non-metallic bits and pieces like sand, rust, and other impurities. Slag buildup happens when this molten gunk decides it doesn't want to float nicely on top anymore. Instead, it sticks to the inside walls of the furnace, like stubborn food burnt onto the side of a cooking pot. Now, how does this sticky mess even form? It's a natural part of the melting process. When you heat up scrap metal to make cast iron, you're not just melting pure iron, you're also melting all the stuff that comes with it. Think about the charge material, the metal you put into the furnace. It might have sand from previous molds clinging to it, or maybe some rust on its surface. When these materials melt and react with other elements in the mix, like silicon and manganese, this reaction creates a lighter liquid substance that separates from the heavy iron, and voila, you have slag. The molten iron is dense and sinks to the bottom, while the lighter slag floats on top. In a perfect world, you could just skim this layer off easily. But we don't live in a perfect world, do we? The chemistry inside that furnace is incredibly complex. The slag can become thick and sticky, especially if the temperature or the chemical balance is off. Instead of being a nice fluid layer, it starts to get clingy. It creeps up the furnace walls, cools down just enough to solidify, and starts building up layer by layer. It creates a hard, crusty ring inside the furnace. This ring grows thicker and thicker with each batch of metal you melt. The slag finds a cool spot on the refractory lining. That's the heat-proof brick lining the furnace, and decides to make a permanent home there. And once it starts, it's a track for more slag. This accumulation is the core of our problem. So, what are the culprits behind this frustrating buildup? Let's line up the usual suspects. First and foremost is the quality of your charge material. If you're throwing in scrap metal that's covered in dirt, sand, rust, or old paint, you're essentially feeding the slag monster. All those non-metallic impurities they end up in the slag. Using dirty or low-quality scrap is like trying to build a precision machine with rusty bolts. You're just inviting for trouble. It's a classic case of garbage in, garbage out. So cleaning your scrap before melting is a huge first step. Another cause is the chemical makeup of your melt. In cast iron production, we often add things like ferrosilicon and ferromanganese to get the right properties in the final product. These are called ferroalloys. But here's the twist. These very elements love to react with oxygen. This reaction, called oxidation, is also a source of slag. If you have too much air getting to the molten metal, or if your charge materials have a lot of rust, which is iron oxide, you're going to create more slag. Temperature also plays a starring role in this drama. If your furnace is running in too low temperatures, the slag becomes thick and viscous. This sticky, slow-moving slag is much more likely to cling to the furnace walls instead of floating freely where it can be removed. On the flip side, running in too high temperature can cause its own set of problems, like burning off valuable alloys and creating even more oxides. Finding that Goldilocks temperature, not too high, not too low, is critical. It requires careful control and monitoring, because even small variations can make a big difference. Finally, let's not forget about the furnace lining itself, the refractory. This material is designed to withstand incredible heat, but it's not invincible. Over time, the aggressive chemical nature of some slags can actually eat away at the refractory. As the lining erodes, it becomes rougher, creating little nooks and crannies where the slag can get a foothold and start its buildup. The type of refractory, the quality, and also your installation process is important. A lining that is not chemically compatible with the type of slag you are producing will wear out faster and contribute to the problem, creating a vicious cycle of erosion and buildup. Now, you might be thinking, okay, so there's some crusty stuff on the furnace wall, what's the big deal? Well, it's a huge deal. That slag buildup acts like a thick insulating blanket. The induction furnace works by using a powerful magnetic field to generate heat. But if there's a layer of slag between the furnace's power coil and the metal, that energy has to fight its way through the slag first. This insulation effect means the furnace has to work much harder and use a lot more electricity to melt the iron. It's a massive energy drain that directly hits your wallet. The problems don't stop with your electricity bill. That growing ring of slag reduces the usable volume of your furnace. If you have a 5-ton furnace, but a thick layer of slag is taking up space, you can't actually fit 5 tons of metal in it anymore. This means each melt yields less product, slowing down your entire production line. The build-up shrinks your furnace volume. This reduction in capacity is a slow, creeping problem that can seriously impact your foundry's output over time. Beyond efficiency, slag buildup can wreak havoc on the quality of your final cast iron. As the molten metal churns and moves inside the furnace, it can catch pieces of that hardened slag from the walls. These bits can get trapped in the iron as it's poured into the mold. When this happens, you get what are called slag inclusions in your finished casting. Ultimately, the most dangerous effect is the risk of metal penetration. If the slag chemically erodes the refractory lining enough, it can create a weak spot. Hot liquid metal at thousands of degrees is relentless. It will find any crack or vulnerability. If it breaks through the refractory lining, it can reach the furnace's copper induction coil. The result is an explosive reaction between molten iron and the water-cooled coils. This is not just a myth, it's an extremely dangerous industrial accident that can destroy the furnace and pose a severe safety risk to everyone in the foundry. Managing slag isn't just about efficiency, it's about safety. So we've established that slag buildup is a formidable foe in our induction furnace. How do we fight back? The battle begins before the furnace is even turned on. Your number one weapon is a clean charge. This means using scrap metal that is as free from sand, rust, oil, and other contaminants as possible. Some foundries use shot blasting or other cleaning methods to prepare their scrap. It might seem like extra work up front, but the payoff is enormous. A cleaner charge directly translates to less fuel for the slag monster, resulting in a cleaner melt, better iron, and a happier, healthier furnace. Next, you have to play the role of a master chef and get your recipe right. This means careful control over the furnace chemistry. You can use materials called slag conditioner, which are like special ingredients you add to the melt. Slag conditioners work by making the slag more fluid and less sticky. A good slag conditioners will combine with the slag-forming oxides and lower their melting point, turning that thick, gunky mess into a more liquid-like substance that is much easier to skim off the top. Choosing the right slag conditioners for your specific operation is key, and it often requires a bit of experimentation to get it perfect. Operational discipline is also non-negotiable. This involves maintaining the correct furnace temperature throughout the melting process. As we discussed, a temperature that's too low makes the slag viscous and sticky. Operators must be trained to monitor the melt closely and ensure the furnace is running within its optimal temperature range. Furthermore, regular and thorough slag removal is essential. After each melt, the floating slag must be skimmed off completely. Leaving some behind is like leaving a seed for the next build-up to grow. Timely and effective deslagging is a critical routine. Finally, there's the physical removal of the buildup that has already formed. This is the hard part. It often involves chipping away the hardened slag with heavy-duty tools while the furnace is empty but still hot, a hard job. In other ways, you can use again as slag conditioners with different dosage of ratio. So regular maintenance is key. Instead of waiting for a massive slag buildup to form, foundries should have scheduled regular cleaning before they become a major issue. Paired with a high-quality refractory lining that resists chemical attack, this proactive maintenance can keep the buildup in check. In the end, managing slag is not about one magic solution. It's about a combination of good materials, smart chemistry, and disciplined operation. Thanks so much for watching, everyone. Your support means the world to me. Until next time, stay on Foundry Plus channel.